Today, we will explore an extremely interesting secret from SpaceX that Elon Musk has just revealed. Have you ever imagined a giant spacecraft, twice the current size, capable of transporting an entire space station in just one launch? This sounds like science fiction, but it is gradually becoming a reality. Not only that, Musk is also quietly developing improvements that will forever change the way we explore the universe. How will this affect the dream of colonizing Mars? Let's find out in today's video. And don't forget to like, subscribe to the channel, and turn on the notification bell so you don't miss any hot space news. Let's get started. Starship is currently one of SpaceX's technological marvels, designed to colonize distant planets and advance deep space exploration. Standing at 400 feet tall in its two-stage configuration, including the Starship and Super Heavy boosters. It is the tallest launch system ever built, surpassing NASA's legendary Saturn V. This massiveness is not only about size but also about performance. Starship is equipped with Raptor engines, advanced engines with an industry-leading thrust-to-weight ratio. What sets Starship apart is its ability to carry large loads. It can carry hundreds of people or hundreds of tons of materials into orbit, serving long-term missions such as building a space station or even transporting infrastructure for a settlement on Mars. The current Starship is seen as an important foundation for Elon Musk's multi-planetary ambitions, where humans can live and work in space sustainably. The Starship V2 version will be tested in 2025 with many major improvements in both performance and design. The ability to carry up to 100 tons of cargo, combined with upgrades in atmospheric re-entry capabilities, allows the V2 to withstand great pressure and temperature during landing, making it more stable in long-term missions. One of the important changes in the V2 is the adjustment of the forward flap system, which has caused some stability problems in previous versions. Previously, the flaps were placed symmetrically at both ends of the Starship, but this created uneven lift, causing the ship's nose to tend to tilt up during landing. To overcome this, SpaceX has redesigned the position and angle of these wings, helping to reduce drag and enhance aerodynamic efficiency. In addition, many important parts such as the nose cone and fuel tank have also been reinforced, improving durability and reusability. These improvements show that SpaceX is gradually optimizing Starship to become a reliable machine for future space missions. Starship V3 is expected to be a major turning point in the history of space technology. With a height of up to 150 meters, it will be the tallest rocket ever built, breaking all records for size. Its power is also superior thanks to the upgraded Raptor engine array, reaching a total thrust of about 10.000 tons, enough to launch twice as much cargo as V2. Not only that, the amazing point is that the cost of each launch of V3 will be only about $2–3 million United States dollars. Much lower than traditional rockets thanks to its completely reusable design. This marks a big step forward in the commercialization of space. When previously the cost of launching satellites or materials into orbit often reached hundreds of millions of USD, V3 will not only serve Mars exploration missions but also bring many new opportunities for businesses and research organizations that want to exploit space resources. With this size and power, V3 can complete huge tasks that previously required dozens of launches, such as building a space station in just 1 or 2 flights. This is the key to Musk's ambition to colonize Mars and open a new era for space exploration. Elon Musk has hinted at a future version of Starship with a massive 18 meters diameter, double the current design. This increase in size is not just about appearance, but also opens up breakthrough transportation capabilities. According to the principle of geometric ratio, when the diameter is doubled, the internal capacity will increase 4 times, allowing Starship to transport much larger amounts of goods, from construction materials to scientific equipment, or even an entire space station in just one launch. Compared to legendary rockets such as the Saturn V, 10 meters diameter, or the Soviet Union's N-1, 17 meters. This version of Starship will become the largest diameter rocket ever built. This has great implications for space exploration and settlement missions. It can carry enough materials for an entire Mars settlement or lunar base in significantly fewer flights, saving costs and time compared to current solutions. But to operate such a large spacecraft, SpaceX would also face fuel, structural, and propulsion challenges that would require a major leap forward in engine technology. Developing a 60-foot Starship would require more than just a massive expansion. It would require a complete overhaul of its manufacturing and operations infrastructure. First, SpaceX would need to build an entirely new manufacturing facility, with massive assembly platforms to handle the larger steel rings. Components like the Mechazilla mechanical tower, which is designed to catch and assist in landing the current Starship, would be inadequate to handle a spacecraft 4 times its mass and size. In addition, the launch system and testing facilities would need to be completely upgraded. The massive thrust from more than 130 Raptor engines would generate temperatures and vibrations far beyond what current launch pads can handle. Cooling, shock control, and environmental protection will be top priorities. Finally, SpaceX will also face stringent safety and environmental regulations. Issues such as shock waves, emissions, and the risk of impact on communities around the launch site will need to be carefully considered during years of testing before official approval is granted. The concept of a giant rocket like Starship is not an entirely new idea. In 1962, U.S. naval engineer Robert C. Truax proposed the Sea Dragon project, a 2-stage rocket 150 meters high and 23 meters in diameter. The unique feature of the Sea Dragon is that it is designed to be launched from the sea, without the need for complex infrastructure on land. This allows for a significant reduction in construction and operating costs. Sea Dragon was built from simple materials such as 8 mm thick steel and was capable of delivering up to 550 tons of cargo into low Earth orbit, many times more than modern rockets. Despite its promise, the project was cancelled due to the political context and tight budgets during the Vietnam War. However, the idea of a heavy, low-cost, reusable rocket has paved the way for the technologies that Elon Musk is developing. Musk has also expressed interest in similar projects many times, emphasizing that developing a larger Starship in the future is completely feasible. Although it may take another decade to realize, the return of this idea shows that SpaceX is inheriting and improving on what previous scientists envisioned more than half a century ago. Elon Musk has made no secret of his ambition to turn Mars into a second home for humanity. However, to make this dream a reality, SpaceX needs a large-scale transportation plan with thousands of Starship flights. Specifically, each Mars transit period lasts 26 months, the period when Mars and Earth are closest to each other. SpaceX plans to launch thousands of spacecraft to bring people, equipment, infrastructure and materials to the Red Planet. These flights not only need to transport enough people but also have to refuel and resupply goods in space, creating a huge logistical challenge. The 18 meters diameter Starship version that Musk revealed will be the solution to this complex problem. The double diameter allows Starship V3 to carry 4 times more cargo than the current one, significantly reducing the number of flights required. For example, instead of the 1.000 Starship flights currently planned, only about 250 large Starship flights would be enough to transport the same amount of cargo and people. At the same time, the number of refueling flights would also be reduced by more than 3.750, helping to optimize resources and costs. This large payload capacity will help SpaceX avoid the need to build refueling stations in orbit, a very expensive and complicated factor. This makes settling on Mars no longer a distant fantasy. With its superior transport capacity, Starship can carry facilities such as housing, food, mining equipment, and even an oxygen production system on Mars, helping the settlement to be autonomous and sustain life for a long time without depending on supplies from Earth. The 18 meters Starship version not only brings advantages to Mars but also opens a new era for comprehensive space exploration, including missions to the Moon and more distant planets. However, SpaceX will have to overcome enormous technical, infrastructural, and regulatory hurdles to realize this vision. Such a massive spacecraft will require new manufacturing facilities, launch systems, and cooling systems to withstand the power of hundreds of Raptor engines. Furthermore, environmental issues, such as shock waves and emissions, will have to be carefully considered before regulators allow the launch. Although the road ahead is long, Elon Musk has asserted that there are no limits to human ambition. The 60-foot Starship will be more than just a means of transportation. It will be a symbol of humanity's desire to explore the universe, bringing us one step closer to reaching unreachable horizons. The new generation Starship is not only a technological marvel but also the key to humanity's multi-planetary future. With its huge size, superior power and optimal cost, it will open a new era for space exploration, from Mars, the Moon to other distant horizons. However, can SpaceX overcome the challenges to realize this ambition? What do you think about the 18 meters version of Starship? Is it capable of changing the landscape of space exploration? Leave a comment below.